new boiler installation and combi update. So we're updating from a cylinder to a combi. My name's Alan Hart, and in today's video I'm going to do a full job from start to finish. I've done quite a lot of jobs in the past where people's asked me to explain in more detail what I'm doing, so when I'm cutting out a cylinder, etc. So in this video I'm going to try my best to do a total step-by-step guide or video to show you what we're doing on this job. I'm also going to go through the products that we're using and why we've chosen certain products for the job. So yeah, let's go and have a look. Please remember, if you're going to work on a gas boiler, you must be gas safe registered or competent to do so. These videos are aimed at trainees and giving them a bit of an insight into what we do as gas engineers. So if we have a look in here on this property, we've put protection down on the floor. If we have a look under the bath here, there's a power shower pump. We need to take that pump out because we're going to put a combi boiler in on this job. We also need to check the shower to make sure that the shower will be compatible with a combi boiler. We don't want any nasty surprises for customer and any leaks. We're also going to take out this hot water cylinder here. Cut all this pipework out. Go up in the loft and take the tanks out as well. We've got an old pipe stat on this. That's for hot water, and then there's a zone valve there as well. So all this, we're going to cut all this out. We've also got a really old boiler. So this boiler is going to come out as well. This is a positive pressure, positive fanned fluid boiler. So all this is going to come out as well. Cut all this pipework out. And what I'll do is I'll explain all this pipework as well and what goes to where on the pipework. We'll just go up in the loft now. We've just got a header tank there. This header tank is for the central heating. It's not piped in correctly, so I'll explain all that to you as well. There's the expansion on the heating is not high enough. Also, we've got some tanks here. These are the cold water storage tanks, and these go to the cylinder, and also they go to the shower. So as I said, the shower is pumped and these go to the shower. Again, I'll show you how all this works. Pete's just doing is it a soundness test, Pete? Tightness test. Electrician, he hasn't brought his sweeping brush today, but
I'll get it tomorrow.
Alright. There we are, look. Positive fan. Yep. So this has got a fan on the positive side on this, so you've got to be careful with this type of boiler because it can blow out through the seals. If we have a look at the header tank, this pipe here, the bottom one, that's the cold feed into the central heating, and I'll show you above the boiler shortly where that goes to. If we have a look at the pipe on the right hand side at the top here, this is the open vent. So if you remember OCP, open vent cold feed pump, and we'll talk more about that shortly. And you need to check with manufacturer's instructions, but normally that would be minimum 450 millimeters above the water level. And this pipe here, this is the overflow pipe. And the pipe behind that, that's the cold mains going into the header tank. If we go back to the boiler here, we can see this top pipe on the left hand side. The very top one is a 22 millimeter pipe, and that's the open vent pipe. So that pipe should be going above the tank in the loft, 450 millimeter minimum from the water level. And the pipe at the back, the 15 millimeter pipe, that is the pipe, that is the cold feed from that red tank that we're seeing up in the loft. So as we can see there clearly, this is not piped correctly because it should be OCP, open vent, cold feed, pump, all on the same pipe. As with all the information that I tell you in this video and in all videos, always check the current regulations and measurements at the time, and each individual boiler will have sometimes they have different measurements. So some boilers have 500 millimeters at like a slope for that measurement. So you just need to make sure that above the water level, I've always done it as 450 millimeter minimum rule of thumb, and if you can do it higher the better, really. But as I say with them and with all the measurements, check in the installation instructions of the boiler. OCP again, open vent, cold feed, pump within 150 millimeters, and again checking your installation instructions for the boiler. Also, some of the tanks and some of the boilers, there's a minimum distance between where the tank can be and where the boiler is. So if the tank is too close to the boiler, then that wouldn't be allowed as well. So that's another thing just for you to check out. On this job today, excuse me, on this job today we're putting a Baxi Platinum boiler in. I gave the customer the option on this job of a Wiesmann 100, a Baxi Platinum, and also an Ideal Vogue, and I let the customer decide which boiler they wanted in this job. Also, we've got a lot of products on this job as well. So what we'll do now, I'll talk through them. I'll show you them as well. So first of all, on the left here, we've got a SpiroTech, and this is an RV2. There's no point me going into how this works. I will give you my opinion on it later on in the video, but SpiroTech have done a really good video, so just search for SpiroTech RV2 on YouTube. So now we've got the central heating filter, and this is the Fernox TF1 Omega Filter. And the shock arrestor that I'm using on this is the Ideal Boilers shock arrestor. So as you can see, we're using different products from different brands. We've also got a scale reducer on this one as well. And for where the condensate pipe goes external, we're using the Condensate Pro insulation so that it doesn't freeze up in winter. We've opened the taps, we've turned the mains off, the mains water, we've opened the taps downstairs. We've also put the drain off hose onto the central heating, so we're starting to remove the tanks now. Just tipping the tank up on this, trying to get as much of the water out of here as possible. Disconnected all the other pipes now. We've just got the cold feed that's still connected. So we've got two header tanks here now, and these are tank fed. So one of these would do the hot water cylinder, and then one of them looks like it might feed the shower. Obviously anything that's tank fed, if you're going to put a combi in, you'd need to update that and make it into, connect it to mains. So I need to take these tanks out now. So again with this now, I've disconnected pipes offside, the cold mains in, but the tank feed I've left on. And what I'm going to do now, just gently tip the tanks up. See there, just put cutters under there. Gently tip them up and try and get as much of the water down the existing pipework. I haven't cut any of this out downstairs yet. So we've started at the top, we've drained the tanks, we've removed the tanks, we've cut all the pipework out, and then we've come all the way down to the boiler. We've cut the pipes out above the boiler, and now we're going to lift the boiler off the wall. So always under control so we don't have no leaks. So we've got the boiler out now, nice and light. No, we're quite heavy with that cast iron boiler. So we're just going to cut all this pipework out now. Right. And then we're going to take this cylinder out here as well. Cut all this pipework down in here as well. So we've put the copper, hose into the copper cylinder, and I'm just going to siphon it now. Yeah. So we've just siphoned it out now on cylinder. So we've just disconnected these off here. This goes to a coil inside, so it's got a coil in there. This is the same water that would be in the central heating radiators that goes through the coil. And then the water in the cylinder is the water that would come out of your hot tap. So it's different water. And as I say, it's got a coil in here, and that's what separates it. Just got Pete just taking this cylinder out. So we've taken the flow into the cylinder out now. If we have a look there, so that's where the tap stat, or whatever they're called, was. And then we've got a zone valve there. So this bit here, that's the flow into the cylinder. This pipe at bottom here, that was the return out of the cylinder. And then that was for the hot water. And then we've got a zone valve here that was for the heating. We've just put it back on temporary, but it's been put on the wrong way around.
Yeah, it's only through on.
Pete's put it on back to front, but
it goes that way.
It would go that way. And that's the flow into the central heating. But we're going to cut all this back. Pete's cut the flow out already here. And we're going to cut this back to make it neat. And we're going to put some of these pipes under floorboards. And then this here, this is the hot pipe that come off the top of the cylinder. And then down there, that's the cold feed that went into the cylinder. So that's the cold that come from your header tanks. And that's there. That's this pipe here. So how that works, cold water down there into the bottom of the cylinder. The cylinder gets hot, and then the hot water comes out of the top of the cylinder there. And then that pipe there, that's the expansion. That goes up to the expansion tank for the cold water storage tanks up in loft. We're very lucky with the gas on this. It's 22mm just down at the bottom. So we only have to update the gas, just this short bit. The flow on the cold water in this property is about 11.5 litres a minute, which perfectly matches a 28 kilowatt Baxi Platinum. The Baxi Platinum comes with a template, so it's very easy to know where all the pipes go. And then we've got a jig, then a pipe jig that we're also going to put onto the wall. So we've just got Darren here now. He's just putting the jig on for the boiler. We've just got Pete taking caps out. These boilers are tested in factory. So when we look at these, you've got a water one, which is the black O-ring.
Yeah.
And then you've got a yellow one, which is the gas. I'll just show him a picture. You just have a look at them. So the black one, that's for water. And the yellow one, that's what we use for gas. And normally you'll see the fitting has a marking on. That's sort of worn off. But normally they'd say gas on there. So you know you've got a gas one. So all you want to do is, normally you'd have a tool where you can mark the depth of there,
yep.
But we haven't got one. So what we'll do, just mark that on there, so you know that it's all the way on, and then just check it. So you check that it's on fully, and then same with this side as well. You mark it,
yeah.
and just check that it's on, so we know that they're fully in. Also, we want to check O-rings are in good condition and that they're in, because sometimes you might have an O-ring that's missing. Not very often, but obviously if you press it, you wouldn't know if it's missing or not. So yeah, I'll let you do that.
Okay. So I'll push this all the way on to N.
Yeah,
that
just
black
push
mark.
them on. And
Make
then
sure that black mark's on there. Push that in.
Yeah.
Black mark's on there.
And then just press it on. Just keep on it. Put on. Now let go.
Okay. The same again with the other one.
Yeah.
Yep. Okay, that's in line.
Pete and Darren are just inside using core drill, and they're just coring out for condensate pipe. I've just used a hole saw and I've cut an hole in the soil pipe. I'm just going to clean this up. I've also got some solvent cleaner. I use this solvent cleaner on the plastic fittings. So if you just use it on the inside of the fitting, clean it up. Also on any of the surfaces that you're going to put glue onto, just clean it off. Clean it off with solvent cleaner, and it just makes it seal a lot better. So that's a strap-on boss that we've put on there. The Condensate Pro termination kit comes pre-made, and you just need to glue it into place. Just get it out of the box, but it comes pre-made, and then obviously that'll connect straight onto the strap-on boss with the clip that's provided. So I've just put that on there now, and to cut the waste pipe I use one of these cutters. This is it's a Rothenberg cutter, and it's for plastic pipe. I've had this for years and years. I probably had this for 5-6 years maybe. Really good, but it's really easy to cut your waste pipe. Sorry for poor quality here, but just to show you how to cut this, it's got a little blade in there, and then it just goes in one direction. So it's really easy. Obviously mark your pipe where you'd want it to be and just cut it, and it's as easy as that. Really good. I really like. So we used to use Class O lagging, and as far as I'm aware, and you'd have to check this for yourself, but Class O lagging, you would need to, and I have checked this myself, but you check for yourself anyway, but Class O lagging, you need to paint it, or you need to use a different type of lagging. But the lagging that we've always used, or what I thought was the right thing to use, and that what's been used on eco schemes and things like that, is Class O lagging. And Class O lagging, you need to paint it, and then you need to, within 7 days, you need to go back and paint it again. So it's really important. This is one of the most important parts of the job. We don't want the condensate pipe to freeze. So this is what I'm using on this job. When we put his clips on here, what I try and do is, if I can, put it over top of the joint. The connection kit comes with this piece that goes into the wall, and it also comes with a pipe snug just to make it nice and neat and tidy as we put it on. And it also comes with some bond and seal, and that's what you do the joints with on there. So we're just finishing off the condensate pipe now. As I say, it's all lagged. Comes into the house in 1.25 inch pipe, and this is a Baxi Platinum boiler. We've installed the flue now, and Darren's just done the electrics. He's put the spur above the boiler. there wasn't much space below. Also the controls, we use an EPH control. So we've got us SpiroTech RV2, the deaerator on there, so that's on the floor. And we've got us Fernox TF1 Omega Filter, that's on the return. We've got the shock arrestor as well. Also the condensate is in big pipe. So we've had to update the electrics, so we've had to do some electrical work on this. So we've got Darren here, and Darren's just going to test it all. So could you just explain what you're doing, Darren?
Yeah, sure. Yeah, so basically we've fitted a new combi boiler. We've taken an old immersion heater out, and we're using the existing, should I say, immersion heater circuit. So as part of the electrical tests and inspection, we must ensure that this circuit is good and sound, that there's a good earth all the way from the boiler all the way back to the main earth terminal here, and also all the way back, the whole installation back to the secondary transformer, which what we call is a ZE test, which is a live to earth test.
So is that what you're doing now with your machine?
That's right, yeah. So what we're looking for is a finite reading in ohms, and the lower the reading the better, because that enables the breaker to blow quicker under fault conditions.
Right.
Let's get in there. So this reading here, 0.25 ohms, is excellent, is a good reading. We've also got a prospective fault current, which we call PFC, of 0.919 kiloamps.
So what does that actually mean?
Well, the system that's in place at the moment, Alan, is what we call TNS, which is terra neutral separate. So we've got a separate earth path back to the transformer, in essence, the secondary substation. And it gives us, the highest reading is 0.80 ohms. So this reading is not only, is basically testing all the way back from this earth terminal here, all the way back to the transformer. So anything underground, so the lead sheath is intact. If that failed and we didn't get that reading under 0.80 ohms, we'd have to phone Northern Power Grid for this area to investigate further.
So it's actually tested, is this testing the earth to make sure that it's safe? Is that
That's it, exactly,
yeah.
so
Okay.
that we achieve these breakers disconnecting in time under a fault condition.
We're going to power flush this system now. Now, normally you would try and power flush before you put the new boiler in, if possible. But with this particular job, because all this here, it all had loads of copper in, and it all had loads of sludge in, and the pipes were really, there were chocker inside. There's no point trying to flush all that out. So what I wanted to do, I wanted to cut all that out first, connect all the boiler on, and then we've isolated the boiler. I'll just show you. So we're going to isolate the boiler, and then we've got, I've just put some stop ends on here now, but I'm going to connect the power flush machine on this side and also on this side. And then when we isolate the boiler underneath there, we can just isolate the boiler, and we're not letting the chemicals and all the muck and sludge go through the new boiler. I'm just going to check inside the boiler as well, make sure it's all safe inside, make sure no one's damaged in the boiler. I don't know if anybody's seen on one of the videos recently, we had a leak from this seal here. So that's made me a little bit paranoid, so I'm going to check that. I'm going to check that seal as well. One thing I do like about these boilers is the water parts, or most of the water parts, are outside the boiler or outside the combustion cover, which means if it leaks, so this part in here at some time in the future will leak, or there's a good chance it will leak. It'll last longer if it's installed correctly and flushed correctly, but it could definitely leak. But it's outside the combustion case. If that was inside the combustion case and it leaked, then it could damage all inside of here. So that's just one thing I do like about the Baxi Platinum. Obviously you've still got the heat exchanger in there that's got water in, but So just because we had that issue with one leaking the other day, I'm just going to check this. So that's just a cane leak detector, but that's fine, and they normally always are fine, but I'm just a little bit paranoid now. So I've got the Powerflush machine on now, got the T's underneath, and the boiler is isolated there. With a Powerflush machine, has this lever here. What that lever does, it means that you can turn it from one way to another. So you're turning the flow. I'm just going to put some F3 cleaner in this. F3 and F5 is actually the same chemical. It's just F5 is a bigger tub. So if I put 2 of these in, it'll be the same as F5. With the new Baxi Platinum, they need to have screws in the flue on these low profile elbows. So you just need to make sure that you've read installation instructions, and if it needs the screws putting in, that you put the screws in. We're just dumping some of the muck out of the Powerflush machine now. Also, this machine has built-in magnets, so it also collects some of the magnetite on the magnets as well. So a little bit like a MagnaCleanse, but unlike a MagnaCleanse, we're also flushing non-metallic muck out of the system as well. We've taken the gate valves out, we've put some full bore lever valves in there, and we've piped the shower back in. What are you doing there then, Darren?
So just installing some safe plates, because I've no option in this case to put the cable over the already pre-cut joist, and I can't put another hole in here due to the regs because there's so much being taken out here. Just put these safe plates in, it just stops the nails being driven in inadvertently.
Customer still had some matching paint, so we've painted where the cement was on the outside, just to make it look nice and tidy. We're going to do some of our checks now to test that the pipe sizing is correct, really. So we're testing the inlet pressure. So if we can see there, we've got 20.2 roughly millibar on the gas, and that's on high. So we've got this in service mode. We're testing it with analyzer, and it's on high. We're now going to turn it to low, and then we'll run that on low. This is a little bit awkward, obviously I'm trying to do it one-handed here, but that's going up to about 21 on low. We need to also check this at the gas meter as well. Fernox now have some little small tubs, and these are really good if you're using an Omega filter. What I do, just turn valves off, and then you can just turn this. You can turn it upside down, and you can put chemicals into that, so you don't have to start buying. These are I think they're about £8 or something like that a minute, because they're like on special offer. But them tubs that you use to squirt in, they're about 20, 23, 24 pounds, something like that. They're just crazy money. When we have a look in the installation instructions on this, this is a 28 kilowatt boiler. And if we want a 35-degree rise on the hot water, so if it's got 10 degrees coming in, you'd have 45 degrees coming out of your tap, then you would expect to get 11.5 litres a minute. And we can adjust that. So what sometimes happens is, oh, I'm getting a bit old. What sometimes happens is, people say that hot water is not very good, and it could be that they've got the boiler's too small for the hot water that they require, or it could just be that the cold water pressure or flow is too much and it's coming through the tap too much. So if you imagine like on an electric shower, it's only going to heat, it's going to go through a coil and come out, and the slower it goes through, then the hotter the water would be. And a combi boiler works a little bit like that. And this boiler is expected to give the water coming in, the cold water coming in, and the hot water coming out. It gives a rise. So the boiler is expected to give, at a 30-degree rise, is expected to give 13.3 litres a minute, and at a 35-degree rise, it'll give 11.5 litres a minute. And some manufacturers, they'll have different figures in here, and what they try and do, or what they do, is they'll show that it gives higher flow rate. So they might say it gives 20 litres a minute, for instance, but it might only give that at a 20-degree rise. So that'd mean that the water coming out of the hot tap would be lukewarm. So you've just got to set that. So on this, I've put a stop tap on here, and what I can do is we can use a flow cup at the taps, and then we can run the taps on full, and then we can just adjust this and just slow it down a little bit if it's going through the boiler too quickly, and then that will mean that the customer will have hot water as the manufacturer's instructions say that they should have. So as always, like I always say, always read the manufacturer's instructions. So we've got about 15 degrees on the cold. So we've got about, on the hot, so this is the hot tap now. We've got about 11 litres a minute. It's about 11 litres a minute. So we would expect that temperature to be minimum 50 degrees really. It may be that it's a little bit more than that as well. So we'll just have a quick look at that. So yeah, it's about 50 degrees, just short of 50 degrees. That's almost,
It's full creeping up, it'll get to 50 and all that.
So you can see it's 50 degrees. So what we're doing with that, we're testing the cold water coming in, and the cold water is 15 degrees. And then we're testing the hot water, and the hot water is 50 degrees. And we've got a 35-degree rise with the flow at 11.5 litres a minute. If you have a look in the book on the boiler, it'll tell you what the litres per minute should be for the rise that you're trying to achieve. So sometimes if you had a bit more flow, then you can adjust it and adjust the flow down a little bit, and use that stop tap underneath what I've put in. You can adjust the flow down a little bit, and then you can get the temperature for the boiler, what you want it to be. We'll just point out the pipe work here. So I've not started polishing it all and things like that. As far as I'm concerned, it's what's inside that matters. So we've flushed the system as well as we possibly can. We've put a filter on, so I'd always put a filter on every job. Normally I would always use an Omega filter. I think the Omega filters are really good. Just put a stop end on there. So them T's, you can use them again in the future if it needed flushing again. I've also left a T there, a stop end, sorry, T with a stop end on. We've got a full bore isolation valve there, and if we ever have any issues with the RV2, the deaerator, we can turn that valve off, and we can turn the valve off on the boiler or on the filter over there, and we'd be able to sort that RV2 out. Same with the filter. if we ever need to take the filter off. Obviously that's got valves on both sides. We've also fitted a scale filter on this. So that's your Baxi Platinum boiler, 10-year parts and labour warranty. We're a little bit restricted on the pipework here because it goes down at the side of the chimney breast, but we've cut out what we can, and this at the bottom here is all going to be boxed back in afterwards. So we've used lots of different products on this installation, and as you can see, I'm not tied to any particular brand. So for instance, chemicals, any of the quality chemicals are just as good in my opinion. So Sentinel, Fernox or the AD products I think are very good. I'm going to talk about these products that we've used now, and I'm going to give you my opinion. Now please feel free to add your opinion below as well, but I'm going to give you my honest opinion, and that opinion may change over time, but I'm going to give you my opinion anyway. I'm also going to add on, I've been asked to show some drawings of how we cut out the cylinders and how we can adapt them for combi boilers. So I'm going to do some drawings on that, but I'm going to show you this. I'm going to show you these first, and then I'll do them drawings as well. First of all, if we start with the TF1 Omega filter, what that is, it's a central heating filter, and it's to help to get the magnetite out of the system. So what you would do, you would flush the system correctly, put your Fernox or any other inhibitor, a good quality inhibitor in the system, and then you'd fit a filter, and then this filter, any little bits that's still left in the system afterwards would go into the filter. I've got a little short video that Fernox sent to me a few years ago, and I'll just show you that now, and then yeah, let's have a look.
So how does this filter work? Contaminated system water enters the filter, and as the water passes through the particle separator plates, the filter uses unique hydronic particle separation technology to disrupt the flow, causing non-magnetic debris to settle at the base of the filter. Then the filter's powerful neodymium magnet quickly removes and collects this magnetic debris. Clean system water then leaves the filter. The Fernox TF1 Omega filter.
So that's the Fernox TF1 Omega filter. I really like the Omega filter. It's brass, so there's less chance of it failing later on, like 3, 4, 5, 6, 7, 8 years time. So that's the reason I choose the Omega filter. You can also, these other filters, so there's the AD filter, which is a good filter. It's a really good filter as well. So there's all different options with filters, and different people have different opinions on filters. So as I say, choose whichever filter you want. Yeah, let's have a look at the SpiroTech now. So the SpiroTech RV2, as I say, best thing to do with that is go onto YouTube and type that in, SpiroTech RV2, and there's a nice little video. I do not have permission from SpiroTech to use that video. I've not asked them. I had a little bit of I cut one of their filters up a few years ago, and I said that I didn't like it. So I don't really have a good relationship with SpiroTech, but the deaerator, I think it's very good. Do I think it's worthwhile fitting on every combi boiler? Not really, because you've got to balance risk and reward. So the risk of the air in the system to the reward that you're going to get, because it's you know, they're quite expensive. So that's what this one is on this job. They're quite expensive, so you'd have to have a decent amount of money in the job to start with to enable you to be able to install one of them deaerators. But as I say, have a look at that video. It's really, really good, and it's really useful to watch. Now what we'll do, we'll have a look at the Combi Pack 4. Now a few of you will have seen that I went over to Ireland. I went over to EPH Controls. I designed my own flap for the front, went and laser printed it. So the EPH Controls, very simple to use, really easy to use for the customer, and also they have the advanced settings in them, so you can have them on open firm, Weber comp, etc. So you can have all the advanced settings on that. I did do a video on that as well, so if you want to know more about the EPH Controls, just type EPH Controls into YouTube and you'll find one of my videos in there about that. Scale reducer, we do not have an issue too much in Leeds, so normally I install boilers in Leeds, but on this install the customer wanted the best job possible, so we put all the joules underneath really, and we just did best job we could for them. So we spent a lot of time there. We spent 3 days there, and there were 3 of us for 3 days. We fully flushed all the system out, and we did everything that you need to do on a boiler installation. This is scale in a hot water cylinder. I have had quite a few requests and questions to do with this video, so I'm going to try and answer as many of them as I can in this video as well. I'm also going to draw some different scenarios to try and help you with that as well. But if you have a look at this video here, so this is a video that I did quite a long time ago, it's about a year ago now, and it's central heating systems, gravity, fully pumped, and there's a lot of information in there, so please go and have a look at that video and hopefully that'll help you. So what I'm going to do now, I'm going to show you how to drain a cylinder and explain how that works. So I'm not very good at drawing, but I'm going to try and explain it the best I can, and if you've got any questions please ask them in the comments below. I have done a video on how a cylinder works, so if you can find that, search for that, and I've cut the cylinder up and it shows you the coil inside, so hopefully that'll be able to help you as well with this what I'm showing you now. But I don't know if you can see that, that's supposed to be a pipe there, and as I say, this drawing is shocking, but you've got your pipe there which is your cold feed that goes into the big volume of the hot water of the cylinder, and then this volume of the water here gets hot, and the hot water then comes out of the top there on that pipe across there. This pipe, this here, this is the coil, or it's supposed to be the coil. So you've got your flow goes in the top from your heat source, from your boiler, goes round here. It doesn't mix with this water, so this is the dirtier water, if you like. This is the water that's got chemicals in, like your inhibitor, and it's got your sludge and stuff like that in here. You wouldn't want that to mix with this water in here. So that's your flow, the top, goes round your coil and then back out the bottom and goes back to the boiler, and that's the return. If we want to drain this cylinder, the heating side of it we would drain on the heating. So if you drain the heating, you drain the rads down, you'd only be draining this coil part of this cylinder. You then need to drain, if you're going to take the cylinder out, you need to drain the water out of the volume of there. Sometimes you'll have a drain off on the bottom of here, and they're not always very good, them drain offs. So what we tend to do, we'll siphon the water out of here. So we'd cut the pipe, obviously we've drained the water, we've turned the water off, we've opened the taps, we've drained as much out of the tanks and as much of the water out as possible. Cut this pipe, and then we take the top, undo that top nut off there, and then we can stick a pipe into here, so like a 15mm pipe with a hose pipe. And then what we're trying to do, I'll just do a different drawing to that now. So as I say, what we're trying to do, we'd put as pipe inside the top of the cylinder, or as hose pipe, or whatever we're going to use to try and siphon the water out. And then this works a bit like an old style toilet. And if we suck this pipe here, this hose pipe, so if we take this outside and we suck on the end of this pipe, what it's going to do, this part of it to start with is going to have air in here. So we need to get this water from here, suck it over the top of here, and once we suck it over the top of there, it will then siphon out of the cylinder, and it'll continually empty this cylinder. All this water will go down and it'll empty the cylinder. So I hope that makes that clear. I know my drawings are not great, but I hope that makes that clear. If you do have any questions on that, please ask them in the comments below. You can buy products these days that you use to siphon the water out. I've never used one, so I can't, I cannot comment on them products. But I'd rather have less products if we can. If there's no, I've done it like that for years. So I've just put the hose pipe in, sucked on the end of it, and it'll empty its cylinder. And then obviously cut all your cylinder out, lift your cylinder out, and just make sure that you put some caps or some on the pipes, because as you lift the cylinder about, there'll be black sludge and stuff that might come out of it. So you just need to be a little bit careful with that. What I'm going to do now, I'm just going to have a look at these other questions here, and I'll try and answer some of them. So I put a picture on yesterday and I asked for questions. So there's 8 comments on here. Why a combi and not stick a new boiler and unvented cylinder in with new weather compensating controls? The system needed updating, and we needed to cut out as much of that pipe work as we could. And also the customer doesn't need an unvented cylinder. The water pressure, they've only got 11 litres a minute on the code. An unvented cylinder would have been more or less pointless, to be honest, because there's only 2 people that live in the property. So in my opinion, a combi boiler was the best solution for these customers, and they don't have to heat water that they don't need as well. And it meant just so much work, and they wouldn't have had no real benefit from that. Step by step explaining what you have done would be good. Well, I think I've tried to do that. So this is probably one of the most in-depth videos I've done so far. And I'm not saying what I do is exactly what everybody else does, but yeah, if you've got any, if you do it differently to what I do, please add some comments below. I'm always open to criticism. That's where, that's how we would all learn, is by, picking up faults with what other people do. I've no issues with that. How much is the cost of an install? The cost, well, that's a very, very hard one to answer, because it's all about who's installing it and what they're going to do. And if they're going to spend the time to flush the system correctly, if they're going to use more expensive products as well. So I tend to, or I do anyway, I try and do the best job possible, and obviously I film all my work, and I put on YouTube, I put the good, bad and ugly jobs that I do. So sometimes we'll do a straight swap and you've got to connect to existing pipes, you've no choice, but I'll put them jobs on, because in my opinion it's not what the boiler looks like on the outside, it's more about the inside. So flushing the system, setting the boiler up correctly, making sure you've got the right flow rate, and just making sure it's all working as it's designed to work, according to the installation instructions. Can you show zone valves and also pump? yeah, well, I think I did that in that cylinder video. So if you click into that cylinder video, that should answer the questions with that. If there's any more questions, please ask them, or even add them back into these comments, and I'll try my best to. I'll do a video on it if you want me to. My guess, Baxi Platinum Combi and own branded controller. Absolutely, that's exactly what's been done on this job. On this job, I actually give the customer the option. I give them an option of a Baxi Platinum. I give them an option of a Wiesmann 100 boiler, and also the Ideal Vogue. All of them boilers, I think are, you know, really good boilers. So that's the options that I give the customer on this job. And the customer went for the Baxi Platinum. Please try and explain in detail. Well, again, I think I've just answered that already. I don't think I can go in much more detail than I have done in this video. It's quite a long video. I'll be surprised if there's many people actually watch this video to the end. It would be great to show prep you do before the actual boiler change, tightness test. Yeah, well, again, I think I've answered. I think I have done that. So we've shown that we'd do a tightness test. So before we start, we'd do a tightness test. We'd do as electrical checks. So prove, use, prove. Always prove, use, prove on any product, any tested equipment that you use. So again, if you're using a gas leak detector, you know, you might go test with hob. Make sure your tester's working. If you use an electrical tester, make sure the electrics. Make sure it's working with a known source. So yeah, I think I've answered that one. So I hope you found this video of some use. If you've got any questions, please ask them in the comments below. I've tried my best to cover as much as possible in this video, but it does take a long time to do these videos and edit them. So if I've missed out, as I say, please add them in comments below, and I'll try my best to cover that in another video. Yeah, and thank you to anybody who's watched this video to the end, and anybody else who supports this channel. It's it's amazing, to be honest. Thank you.
TF1 Omega Filter. So how does this filter work? Contaminated system water enters the filter, and as the water passes through the particle separator plates, the filter uses unique hydronic particle separation technology to disrupt the flow, causing non-magnetic debris to settle at the base of the filter. Then the filter's powerful neodymium magnet